In this video we're just going to be transforming some variables, so it'll be using the generate command or the replace command, and we're just going to be transforming variables, so adding, dividing, multiplying using natural logs, so forth. So based on the last video, I've just eGen, and now let's say that I want to create some sort of index. So for my index, I'm going to generate the index, and let's say that we want to make it equal to the natural log of GDP plus the difference in the CPI minus the unemployment rate divided by 5.5, or let's say the difference in the unemployment rate from 5.5%. So we can generate our index equal to, for the natural log, we want to take ln. That's going to be the natural log command, so the natural log of GDP. Then we'll add on the difference of the CPI, so we can go, or we'll just do the CPI. So CPI, let's do the natural log of the CPI as well. And then let's say that we want to use the difference in the unemployment rate. So we go UN, our plus UN rate, minus our 5.5, which is our threshold. And if I run that, I have my new index number here. So if unemployment is above the threshold, it's going to be higher, GDP is higher, so forth. So it's not a very meaningful number in economics, but it shows us what we're doing as data. Then if I want to graph that over time, we can just do a two-way. We'll do a line index day. Obviously, you have to sort that. And then this is our index. So we see it trending upward, but unemployment rate is really throwing it up and down. Another thing that we may want to do is say, well, what is the mean of unemployment? So we get the mean of unemployment, we can just go sum the unemployment rate. And we know it's 6.07%. So in here, we can make use of that. So in a do file, I don't need to know that number and memorize it and type it in. I can just call it from memory. So I can say sum UN rate. And then I'm going to generate index 1 equal to UN rate minus, I'm going to go R mean. And that R mean takes whatever this R is telling us from whatever command we previously used. It stored the mean, in this case the mean, under there. So I could do N for observations, or STD for standard deviation, so forth, or min and max. But here I just want to take the mean. So I'm taking the unemployment rate minus the mean of the unemployment rate. If I go ahead and run this, my index here, so I have, this is 5.000002, so that minus 6.087 gives us this number. So then if I look at, we're going to do a two-way. And then we'll add another one. And this is what I get. And sure enough, my index it looks exactly identical because I'm just subtracting a constant, so it should be the exact same correlation. The correlation should be perfect. They should be perfectly correlated, except they have different scales. So here we have a scale of 8. Over here it's 2, which is just a little bit below 2, or minus 6.0, whatever this number, 87%. So that's the only difference. But you can see that it actually did take away the mean based on these two axes. If we want to square a variable, we can generate CPI equal to, or let's say that we want to replace the CPI with the CPI squared. So we can just replace CPI equal to CPI and call it to the 2. And then if we look in our data, now our CPI is the square of the CPI, what it was. The last thing that we want to do is we can always divide and multiply in here as well. So let's say that we want to take gen index 2 equal to, we're going to do, let's see, GDP divided by 1,000 times index 1, which is the difference between unemployment and the natural rate of unemployment. So we're taking this GDP divided by 1,000 and multiplying it by index 1. We can go through and do that. And then we have some sort of number here as well. So here GDP divided by 1,000 times 2.02 gives us 11.7. So we can always do that as well. So overall, this generate command is very, very useful. So we can generate new variables, and we can use the replace command, and we can add, divide, multiply, take the natural log, square things. We can take the square root. So the generate command is very, very useful in this case. And then also, we may want to take something that we have in memory. So if we were going to do this for a bunch of variables, I don't want to spend the time memorizing what these numbers are. So in code, I can just take the R mean. In fact, if we just go to sum, help sum, we're using the summarize. So we go down to the bottom. And here's everything that we can take from the summarize command. So I was using the rmean, which takes the mean. I could use rn for the observations, rmin, rmax. I can take the percentiles, the variance, kurtosis, sum, standard deviation, so forth. So I can use all of these commands as well after I summarize a variable.